B1, B2 and B3. No? So some students are still joining. I think 5 to 6 students are left to join. So let them join first, then we will start our lab. Okay, so in the last lab we have just taken the attendance, and from this lab we will start our experiment session. So do you have your syllabus of experiment, or else we will mail you? So your first experiment is okay. We will mail you. Your first experiment is tensile testing of mild steel specimen in universal testing machine. So all of you have used universal testing machine in your earlier experiments in MD1. Have you done any experiment on UTM? Have you done any experiment on UTM earlier?
No, ma'am.
Yes. No. What you have used or not? Someone was saying something, I was not able to hear it. Okay. Yeah, okay, so let me show you one video of universal testing machine, and what is the first of all, let me tell you what is the purpose of using this UTM. Okay, so UTM is actually used to test a material, and the specimen we use it is the tensile specimen, and it's actually this method of testing is used to find out whether how strong the material is, and that how much it can be stretched before it actually breaks. Okay, before its failure, how much material can be stretched. So uh, um, I will share my screen with you so that you can see that video. Are you able to see this my screen?
Yes, ma'am.
Okay. So this is a universal testing machine, and this is a tensile specimen. Okay, so the area of interest in this tensile specimen is the gauge length, and all the measurements whatever we make on this gauge length only. And here it is for gripping in the machine. This part is for gripping. Okay, so this is a UTM. So I'm playing this video. You carefully see it and listen to it first. Let me know if you are able to hear its voice or not. Are you able to hear it?
No, ma'am.
You're not able to hear it? Okay, so let me explain you. So this is a UTM machine, and it is have you ever seen UTM machine in college? I just want to know it. Have you seen such type of machine in our workshop or in any lab in college? Yes or no?
No, ma'am.
नहीं देखा है. Okay, so this is universal testing machine. So it is the loading part of the machine. So it is the actually controller of the machine. So from here we apply the load on the machine, and so this is the controller part, and from here we apply the load on the machine. So here it is a hydraulic fluid is there in this part of the machine. Yeah, here is hydraulic fluid is there, and there is a ram below it, and when we apply the load, this ram pushes these arms. These are the two movable arms of the machine, and this is the fixed part. So in this part also, this bottom part is fixed and this upper part is movable. Okay, so when we apply the load, that is, we apply the tensile load on the machine by moving this crosshead in the upward direction. Okay, and this is the tensile specimen. These are the gripping arms. We fix these arms on the crossheads of the machine, and when the load is applied on from the ram to the fluid, then these arms move upwards, and a tensile load is applied on the tensile specimen. Okay, are you able to get it? Are you able to understand it?
Yes, ma'am.
Okay. Yeah, so I will share this link also with you so that you can listen to it carefully. Yeah, so after this, so the original tensile specimen shape is like this, and we are just measuring the gauge length by the change in length of the gauge length. Okay, so original is L and the final is L1. So final we see at the fracture point, that is when the specimen breaks in two pieces, and this specimen, as it is a mild steel specimen, so it will show a cup and cone type of fracture. So I think you have read about types of fractures, no, in your strength of materials, that theories, failure theories. So here it will be a cup and cone type of fracture of this specimen. And with this we plot a graph, that is stress strain graph of the material. So the main objective of doing this tensile testing is to find out the yield and ductility of the material. So this point, ये तो पढ़ा होगा ना? You have read about the stress strain curve, no? For ductile material and for brittle material.
Yes, ma'am.
Okay. This type of plot we get from the this machine. I will send you the link for this so you can see this video complete. Okay. So this is for a mild steel graph. So it is an engineering stress strain curve. It is not the true stress strain curve. Because in this, the area of cross section, we are assuming that the area of cross section is not changing. That is, if A is the area of cross section, yeah, if A is the area of cross section, initial area of cross section, then up to the fracture point, we are assuming that area of cross section is A only. But in true condition, we can see that area of cross section is decreasing. So the true stress strain curve is always goes upside than the engineering stress strain curve. Okay. So after so these are the points. Here is yield strength. Before the yield strength, there is a limit of proportionality. It is somewhere here. So this is the limit of proportionality, and after that there are two yield points, upper yield point and lower yield point. It is not shown in this video. Let me see if there is another video. Yeah, you can see here. Are you able to see this screen? Are you able to see this stress strain curve?
Yes, ma'am.
Not in the video. I have opened a other stress strain curve.
No, ma'am.
No. Okay, let me show it. Just a minute. Yeah, now you might be able to see it, no? Stress strain curve for mild steel. Now you are able to see it?
Yes, ma'am.
Okay, so here it is clear. So A is the limit of proportionality, that is the stress is directly proportional to strain up to point A, and the Hooke's law is valid only up to point A. Okay, after that B is the elastic limit of the curve. Up to this B point, the material is in elastic range, and after B, it goes in the plastic range. That is, there will be a permanent deformation of the material, permanent deformation of the specimen, tensile specimen. Okay. Then C is the upper yield point and D is the lower yield point. So for our actual calculations, we use the yield point to be the lower yield point, because upper yield point is actually it can be like changed due to the speed of the machine or the loading condition of the machine. So we don't consider C as the yield point. The actual yield point is the lower yield point only. And after that, as we increase the load, that is, we increase the stress in the material, uh, the strain increases, and the this is E is the ultimate tensile strength of the material. Then after that, the strain softening is there, and then the at a point F, the fracture occurs of the material. Okay, so this is the stress strain curve for mild steel. So mild steel is a ductile material. Okay. So for brittle material, we don't have any specific yield point. For brittle material, we just have the we just have the yield point and the UTS coincide in case of the brittle material. Have you seen the graph for brittle material? No? In your strength of material, you might have read about stress curve for my this ductile material and brittle materials. Yes or no? Okay. So here we can see a clear yield point for the ductile material, but for brittle material we don't have this yield point, and this yield point actually coincide with the origin, I think. This yield point coincide with the origin. There is no elastic region. It after certain point of time, it just fails the. It just have the breakage of the material. There is a breakage of the material. Okay. So this is all about the tensile specimen, and let me show you one more photograph of the tensile specimen. Just a minute. Are you able to see this? So this is actually a tensile specimen, and this is the overall length of the specimen, from which this is the gripping section. This goes inside the crosshead of the machine, UTM machine. Then these are the shoulders, and this is the gauge length, of which we on this gauge length only we plot this stress strain curve. Okay. Write-up part, I think we will give you afterwards. It is the basic understanding of the UTM and what is a tensile specimen and why do we perform this test. Okay, so we perform this test to um, find out that how strong the material is. Okay, and it's what is its ultimate strength, what is its yield strength. So I have shown you this graph for the mild steel. So you try to plot the graph for this ductile for brittle material. This is for ductile material. You plot the graph for brittle material, and you also write out the difference between the graphs of stress strain curves of brittle material and ductile material. So these two things you have to do as an assignment for your next lab. Okay. Write down these 2 points for as an assignment for your next lab. And और क्या करवाना है अभी? Okay, everyone have joined now. Some people have joined afterwards, no? So, okay, so anyone have any doubt in this? Have you understood this? Okay, कोई डाउट नहीं है किसी को? Okay, so let me take attendance now. This is batch 1, 2, 3, no? Could we just draw the graph? Yeah, you draw the graph for the brittle material and try for some other material also, like for aluminium also you can try, and you can try the graph for aluminium, then rubber and glass. Okay, so for 3-4 materials you draw the graph including brittle as well as the ductile materials. And so first assignment will be this, and the second assignment you have to write the difference between the graph stress strain graph for brittle material and for ductile material. Okay, so one difference I have told you that in brittle material you don't see this yield point, clear yield point is not there, and other difference you can find out and try to plot this true stress strain curve also and understand the meaning of it. Okay, so try to do these exercise for the next lab. So attendance, just a minute. So roll number 1 is Harshini. 1 present?
Present, ma'am.
Okay.